All right, so for this next section, we're looking at amplitude and period of sine and cosine functions. So the value in front of, or the lead coefficient here of your cosine function, that determines your amplitude. So the absolute value of, I'm just going to go ahead and write this like this, a cosine x, the absolute value of this a, that's equal to your amplitude. So the amplitude, again, is just referring to the distance from your graph's center line. So center line of cosine is just 0. So the amplitude is the distance from here to here, or from here to here. If you're given a graph and asked to find amplitude, you would take your maximum minus your minimum value and divide by 2. But if you're given an equation, you can just look at the value in front of your cosine or your sine function. So I know that our amplitude is 4 for this particular problem. So the other thing we are asked to find is the period. So I want to look at this graph of this function so that I can show you what it means when it's asking for the period. The period of a function is measured from the easiest way to look at the period is to go from peak. Actually, I want to highlight that, is to go from peak to peak. That gives you your period. It's when your graph completes one full cycle. So, and then it starts over, right? So here I'll show a different color where it starts over. Boom. Okay. So on the graph, that's what the period looks like, but I'm going to show you how to calculate it from the equation. So from this equation, I'm going to rewrite this again, a times cosine bx. This value right here helps us to find the period. So remember, when you multiply a function, it doesn't matter what function you're working with. When you multiply by something, it either shrinks or stretches your graph. So if you think about it, that b value is going to affect, it could make your graph get closer and closer together, or it could make it stretch out the period. So we're going to look at what causes it to stretch and shrink, but first let's figure out how to calculate the period using this equation. So your period is equal to 2 pi divided by b. So in this particular problem, b is pi over 3. So it's not pi over 3x, it's just pi over 3. That is not your period. That helps you to determine your period. So 2 pi divided by pi over 3, that's 2 pi times 3 over pi, and that gives us 6. So the period of this graph is 6. And this wasn't referring to this example, I just needed the graph here so I could show you. So if you're looking at that going, that doesn't seem right, that's why. Okay. So now we're looking at amplitude, period, and phase shift. So again, amplitude. Oops, I said amplitude and then I highlighted period. So amplitude is this value here. Phase shift is found here. And period, we're going to use this 2 to help us out. We're going to need to change around or rearrange how this is written so that we can pull out the correct phase shift. So we're going to look at a little bit of instruction on this one. So again, this helps us out. Period is 2 pi over b. But what we want to work on rearranging is this function right here, because we need to write it in a way that we can easily identify our b and take into account how that affects our phase shift. So on the problem that we have 2x plus pi over 3. So I'm going to factor out that 2. So 4 cosine 2. And now we're left with x plus, so pi over 3 divided by 2 becomes pi over 6. And if you want to check that, just 2 times pi over 6. Oh, yep, that's pi over 3. So we know we're mathematically that we are correct. And then we also have a vertical shift of plus 3. The question didn't ask for that, but it's always good to know how to do that as well. Okay, so it asks us to identify the amplitude. So amplitude. It asks us to identify phase shift. That's our shift left and right. So now that we have it in the proper form, we can easily identify the phase shift as pi over 6. So x plus pi over 6, that's going to be a phase shift of pi over 6 to the left. If we had x minus, that would be a phase shift of pi over 2 to the right. And then our plus 3 is going to shift our center line of this graph up by 3 units. So when I say center line, let's just do a rough... so if you don't have if you're not shifting up or down, your center line is the x-axis. But if you shift up, let's say this graph shifts up plus 3, then it means your center line becomes 3, which means that's the line that cuts your graph in half. Okay.